Hi, this is Jayanam again with a new comparison video on programming with the game engines Unity and Unreal Engine. I created a very simple project for both engines and point out the differences for programming by using this example. So here's the basic concept. You have a simple cube and an FPS player. This cube has a box collider that is used as a triggering component that reacts when the player is entering and leaving. On entering, the cube is hidden, and when the player leaves the box area, the cube is shown again. A very simple project. Okay, so let me show the Unity solution first. We are here in Unity 5.6 and this is a basic setup, an empty project, and I will add a cube for the floor and then the cube for which the visibility is toggled when an FPS player is entering or leaving an area around this cube. Alright, I need an FPS player for this project, so I will import the characters package. It contains a prefab for an FPS player which I'm going to use. Okay, and now I will drag the FPS player into my scene. Here we go. And now I can start the game and test if this works, if I can walk around in the environment. Yeah, alright. Okay, and now it's time to add a script. I will use a C# script. You could also use JavaScript or Lua if you like, but I think C# is the most powerful solution. And in Unity you have to code. There is no alternative to coding. There is no visual scripting editor. At least not out of the box. You could buy Playmaker, for example, but the default is that you add a script. And I name this script CubeScript. And when I double click this, my IDE, my integrated development environment, in my case Visual Studio 2015, is opened. You can also use MonoDevelop if you like, both are available for free. So here is my script, my CubeScript. It is derived from the class MonoBehavior, and MonoBehavior comes with a couple of very useful methods, for example for entering or leaving a trigger area. But before I can use this, I have to define my trigger area, and I will use the box collider for this. This component, the box collider, is added by default to the cube, and to turn it into a trigger I just have to check this is trigger. When it is defined as a trigger, then my player is allowed to enter this area, but I'm notified in my script when I'm entering or leaving. If it is a collider, then my player is prevented from entering, and this is definitely not what we want. Okay, the setup is completed, and now let's return to the script and write the logic. I need to be notified when my player is entering the trigger area. So it's always a good idea to open the documentation for the Unity API, and here we have a method called onTriggerEnter, and we can just copy this little snippet here and paste it into our script. This is called onTriggerEnter, and in this method we know that some object, perhaps the player, is entering the trigger area. And once you get used to the concept of APIs, then you know that this kind of method will have an antagonist, and in this case this is the method onTriggerExit, which is called when the player is leaving the trigger area. Okay, now let's implement the logic for displaying and hiding the cube. onTriggerEnter, I get the component renderer and set the enabled to false, and in the method onTriggerExit I will set it to true again. And that's it, we are ready to start the game and check if the requirements are implemented correctly. Yes, it is hidden and displayed again. Really cool. And now you could create a folder called prefabs and drag your cube with the attached script to this folder and reuse this component in your scene as often as you like. Okay, that's the Unity solution. I think it wasn't that hard. Now let's come to Unreal Engine 4. Unreal Engine has a visual scripting feature called blueprints. These can be regarded as a kind of visual representation of source code. So let's implement our project by just using blueprints. So here we are in Unreal Engine 4.16, and I'm going to create a first-person project and call this cube test like the Unity project before. Okay, this is the first-person template, the level, and I'm going to delete all the cubes here, all the stuff except of the floor. And here's the first-person player, and I'm also going to hide the gun and the arms and all this stuff so that we have a project that is comparable to the project we had in Unity. Alright, we can walk around with the player. Nice. Now let's add a blueprint. Right click here and select blueprint class, and as a base class we select actor. Then I will name this cube underscore BP for blueprint, and then double click this, and this is the blueprint editor. And now we can add our objects that we need. We need a cube and we need a box collision component. So let's add a static mesh. This will be the cube, and we can already assign the mesh here directly in the blueprint. Here it is, the cube. Here we go, great. And now let's add the box collision component. For the box collision component, I will set the extent to, let's say, 300. Okay, we're done with the UI part. Now let's switch to the event graph and implement the logic. So as in Unity, we have to bind events so that we are notified when the player is entering and leaving this box area. Like we did in Unity, it's a pure analogy. So the first event that I bind is on component begin overlap. This is when the player is entering this area. So here is the node, the function. It has a lot of parameters. For example, we could check which actor is actually entering this area and all this stuff. Now let's bind the second one, which is on component end overlap, which is called when the player or another actor is leaving this box area. Then I get my cube, for which I have a reference here, and use it to call a function to set its own visibility. So let's check type in visible or vis, and here we could check if the cube is visible, we could set the visibility, and we can also toggle the visibility, and that's cool. And I think I will actually use this toggle visibility in both methods, when an actor is entering or leaving. And I think this is everything we need to implement the requirements we have. So let's start the game and test this. Okay, we are entering this area, it is hidden, and we are leaving and it is visible again. So this works great. And now let's do exactly the same using C++. So right click here into a folder and select new C++ class. As base class again, we use the actor, press next, and set a name for your class like cube actor, for example. Okay, then create the class, and after we did this, a header file and the CPP file are generated, added to the project, and Visual Studio 2015, in my case, is opened, which is my integrated development environment. And here is the CPP file, the implementation file of the cube actor. You can see the constructor, the begin play, and the tick method. Now let's switch to the header file and create all the stuff, all the variables that we created by using blueprints. So let's start. The first thing we need is a static mesh that represents the cube. The class is useStaticMeshComponent and we name this cube. I define this as a property so that it is editable anywhere and also read and writable by using blueprints. Okay, let's copy this and add a U-shape component. This will be our box collision component. Okay, and now it's getting a bit more complicated. We need the callbacks, these methods onBegin and onEndOverlap. So let's open the Unreal Engine API documentation for C++ for the method onOverlapBegin, and let's copy the whole implementation here. Just Ctrl+C and now press Ctrl+V to copy this into the header file, remove the class identifier and the implementation, so that we just have the declaration of the method in our header file, and then I switch to the CPP file and also copy the whole implementation in and change the class, because the class is not the one used in the documentation, it is the acube actor. Okay, also remove the point light, we don't have a point light. We will add the implementation later on, but now I will do just the same for the onOverlapEnd method. Again, I switch to the documentation and copy this like I did it for the method before. Okay, great. We defined the components, the cube, the box collider, and now I'm going to create them. The actor class has one root scene component, which I'm going to create now. This can be done by using the method createDefaultSubObject. And this is a useScene component. And after that, I will create the static mesh for the cube, then the box collision component, and attach it to this root component. And this is actually the same UI setup that we defined in our blueprint, but just by using C++ code. Okay, here I'm binding my callback methods, the onComponentBegin and endOverlap. And after that, we are ready to create the very small implementation to toggle the visibility of the cube. So this is the callback onOverlapBegin, and this is a very easy implementation. We just call cube toggle visibility, just like we did it in the blueprint. And you can call the toggle visibility in the onOverlapEnd as well. And now you can drag the cube actor into the scene, and we don't see a cube. We didn't assign a cube, and the extent of the box collision is the default. So we could assign this in the editor, but I recommend the following. I recommend to create a blueprint, right click onto this cube actor and create a new blueprint with this cube actor as a base class. Then set a name and press create blueprint. And now that we created the blueprint, we can open the editor and assign the box collision object and the cube as we did for the blueprint without our own C++ implementation. And now we have both worlds. We have the blueprints for the UI part, and we have the C++ implementation that we could extend and use, for example, when it comes to implementing really complicated logic like array cast or some calculations or something like that. Okay, now let's compile and drag this blueprint into the scene and test it. I'm entering the box collision area, it is hidden, and I'm leaving and it is displayed again. So guys, this was a very simple example for using blueprints and C++ with Unreal Engine 4. And here's my personal opinion about blueprints and C++. I use blueprints if I have tasks that can be easily solved with them, but the optimal way is to be able to combine blueprints and C++ to implement the best solution for a particular technical requirement. So let's sum it up. In Unity, you have to code. There is no visual scripting out of the box. There are third-party assets like Playmaker or something like that, but you have to buy them. Coding with C# or JavaScript in Unity might be for beginners a bit easier than using C++. On the other hand, C++ is a powerful language and it's really good to know it. An alternative way for coding in Unreal Engine 4 are blueprints, a great feature for visual scripting. So decide by yourself which engine and programming features fits best for you. If you like my channel, don't forget to subscribe to not miss a future tutorial. Think about supporting me on my Patreon, and I hope to see you soon on Jayanam.